All right, let's get you ready for the Unit 1 first part of Investigation 3 quiz. For number 1, it says, the number of electrons in a neutral atom is always the same as the number of what? Well, in order to cancel out their negative charge, we need it to be the same as the number of protons, because protons are positive, electrons are negative. So if you've got, for example, 6 protons and 6 electrons, the overall charge of the atom will be neutral. There's my explanation there. All right, number 2. It says there's 3 stable isotopes of neon, and I believe that this meant magnesium. Okay, magnesium 24 is the most popular, 79%. Then magnesium 25 and 26. For each of these, it says list the number of protons, neutrons, and electrons. Assume each atom is neutral. Well, you got to go to magnesium square and look up what number it is. It's number 12. Automatically, that tells you there are 12 protons and 12 electrons in each of these. So the thing that's different is the number of neutrons. The first one, 24 minus 12 protons leaves 12 neutrons. But the next one weighs 25. 25 minus 12, that one has 13 neutrons. And magnesium 26 minus the 12 protons, 14 neutrons. And their symbols are all going to be slightly different. They're all going to have Mg with a 24 at the top. With their mass at the top. And then there's always going to be a 12 on the bottom. If you were to pick up and weigh a single atom of magnesium, the atom would most likely have a mass of what? Well, look at their abundance. 79% of the time, it would weigh 24. How many neutrons does that magnesium 24 have? 12. Explain your choice. You could also explain by noticing that the average atomic mass of a magnesium atom is 24.305 AMU, which is closest to magnesium 24. Okay, based on their numbers, though, you're supposed to calculate the average atomic mass of magnesium. Okay, so we're going to need that little chart up here. So it weighs 24 79% of the time, so I'm going to change that to 0.79. It weighs 25 10% of the time. And it weighs 26 11% of the time. Multiply and add that all together. It ends up coming out to be 24.32 AMU, which is pretty close to what the periodic table actually says. The 2 most common isotopes of rhenium are rhenium-185, which occurs, move that decimal 2 back, 0.374, plus rhenium-187, move the decimal 2 back, 0.626. The average atomic mass would be 186.252 AMU. All right, so then we're supposed to circle which one's more common. Use the average atomic mass on the periodic table to help you. So for boron, its average atomic mass is 10.81. So that would round to 11. For nitrogen, it's 14.01. That would round to 14, the nearest whole number. The next one is 35.45. That's closest to chlorine 35. Looking up nickel on the periodic table, it says its average atomic mass is 58.693. That's closest to 58 over nickel 60. Next one, sulfur is 32.06. That's very close to 32. And sodium is 22.99, very close to sodium 23. Next, explain the difference between mass number and the average atomic mass. Mass number is for a single atom. It's the number of protons plus the number of neutrons. The average atomic mass is an average of all atoms in the world for that element. So it includes all isotopes, atoms that have a different number of neutrons. So those can bump up the average or bump it down. Okay, then we've got a table. It's important you know how to write isotope names and symbols. So silicon, look up its number on the periodic table. It's number 14. So how would you name this? Silicon dash, you name it after its mass. So we got to figure out its mass. 14 protons, 16 neutrons. That adds to 30. Then for the symbol, you always put the mass in the upper left corner and the atomic number in the lower left. Next one says an atom with 25 protons. Look up what element has 25 protons. It's manganese is number 25. What would its mass be? It has 25 protons, 30 neutrons. Add those two numbers. Has a mass of 55. Manganese is Mn. Put the 55 in the upper left corner and the 25 in the lower left corner. A zinc atom, zinc is number 30. So 30 protons. And this one's got 38 neutrons. That makes zinc 68. So 68 in the upper left corner and 30 in the lower left corner. Something with 35 protons. Well, I looked up element number 35. It's bromine. 35 plus 46 tells you the mass is 81. So you'd have bromine with an 81, and then the lower left would be a 35. How many protons and neutrons do each of these contain? Iodine on the periodic table is number 53. So protons would be 53. If its total mass is 127, I've got to do a subtraction here to get the number of neutrons, which would be 74. Same thing for gold, only gold is number 79. Whoops. So 197 minus 79 is 118 neutrons. Tin is number 50. For neutrons, 124 minus 50 makes 74 neutrons. Okay, and then these are a little easier because you don't even have to look it up. It tells you copper's number 29. 63 minus 29 to get the number of neutrons, 34. Again, this is number 19. Mass number minus number of protons is 23 neutrons. And the last one, it tells you it's number 48. 116 minus 48 is 68. Different elements have different numbers of protons, while different isotopes have different numbers of neutrons. How do the masses of protons, neutrons, and electrons compare? Protons and neutrons are the same. They both are 1 AMU. Electrons are so tiny. They still have mass, but they're about 1/2000th of an AMU. Boron atoms can have 5 neutrons or 6 neutrons. This is tricky. How many electrons would you expect a boron atom with 6 neutrons to have? Well, boron is number 5 on the periodic table, so 5 protons. If this atom is neutral, we would expect 5 electrons. So they're throwing in some distracting information there about neutrons that you don't really need.